All right, Matt. Well, I'm excited about this one. I reached out to Matt about this talk because GraphQL is coming up more and more in Bug Crowd's bug bounties, and we've actually been trying to find more people that have this specific skill set. So I was excited that someone like you is out there already talking about this stuff. So, without further ado, you're welcome to take it away, Matt. And we've got a live chat on our Twitch channel. If you are able to load that up and watch that, or if we have time at the end of the talk, we can take questions from the Twitch chat and answer over the stream.
Cool. I'll probably just hit them up at the end.
Cool. Sounds good.
Cool. Thanks for having me on. I really appreciate it. I found my first kind of interaction with GraphQL was when I was doing a hack the box, just kind of playing around on there. And I ran into this endpoint that looked a little bit strange, and it accepted requests and gave responses that were a little bit strange. And after doing some digging, I realized it was this thing called GraphQL. And I thought, if I never have heard of this, maybe there's other people that have never heard of this, and you could easily be testing an endpoint like this and not actually realize what you have in front of you. So I did some research and I kind of put this talk together, along with built a tool that I'll show at the end that helps you do pen testing of this infrastructure, because the way it works is pretty interesting. So my talk is called Rest in Peace, Abusing GraphQL to Attack Underlying Infrastructure. And I say rest in peace because GraphQL is kind of designed to replace REST in a way and solve some of the problems. Gotta say that nothing I talk about reflects the views of my employer, all that good stuff. So today we're gonna kind of talk about GraphQL at a high level, understand kind of what it is, just enough to be dangerous. We're not gonna go too deep in the weeds because there's a lot of documentation around it. We're gonna take a look at some of the vulnerabilities in the wild that have been disclosed surrounding using GraphQL. We're going to look at how to abuse it and some attack techniques, and then at the end, kind of some ways that if you are a developer working with GraphQL, you can protect it. So first, what is GraphQL? Well, GraphQL was created by Facebook for internal use in 2012. I believe they used it for their Messenger app or something like that. Not entirely sure, but it was released open source in 2015. And it's essentially a query language for your API, as well as a server-side runtime for executing those queries using a type system that you can define custom to your data. So that gives it a lot of flexibility, and we're going to talk about what that means a little bit later also. Like I said, it was designed to solve some of the problems that REST APIs suffered from, mainly having to make a lot of requests to a lot of different endpoints to get data back that you kind of have to, process and display in a way. So it decreases latency a lot because with GraphQL, you can just make one query to a query API and get large amounts of complex data back all on a single request. So as well as the fact that you can kind of integrate it with your current infrastructure, but you're going to have to do a lot of refactoring. But it's not impossible to do. So you can see on this slide here that I have a little diagram. I took this from a Medium article, and it essentially shows the difference between a REST API and a GraphQL API there. So you can see that the client's just sending a single request. GraphQL takes that request and you can see it kind of parses that out and passes it down to what are called resolver functions, and it gathers all the data back and sends it back to you as one large response. So, but GraphQL is adding more complexity to what is already really a complex puzzle, right? So, and with more complexity leaves more room for error. You can still attack the underlying code base just like you would with a traditional REST API. We just need to understand the path to get there. So commonly there's implementation errors when people are standing up GraphQL, and we're going to try and look at some ways that you can take advantage of those implementation errors also. I made this slide that's really hard to watch because I wanted to kind of give people an idea of how many companies are out there leveraging this technology. You'll see some really big names go by. And with its increasing popularity is the increased chance that our data can get compromised, right? So as businesses continue to adopt GraphQL, it becomes increasingly important to be able to properly test these endpoints for security issues. I won't make you watch this slide all the way to the end. I think you kind of get the idea. So we all have problems, right? While they are having to figure out how to properly set up this technology, developers are having to figure out how to properly sanitize and validate all their user input and all that. Hackers have to do the same thing. We have tons of documentation to read. This is just kind of the outline from GraphQL's docs. There's a whole bunch of stuff to know. Schemas, which we'll talk about what that is a little bit later, can be very large and complex, and you have to reverse engineer them in order to be able to attack them. Until recently, there isn't a lot of attack tooling or tutorials out there to give you a better understanding of what you're actually facing. And at the end of the day, you know, the same vulnerabilities still exist. We just have to modify our attack methodology to be able to adjust to this new landscape, right? So let's get to know GraphQL a little bit. So GraphQL is all kind of based on what's called a schema. And a schema is basically a collection of object and type definitions, along with a few other things. And each field in your schema maps to what's called a resolver function. And that resolver function is where all your application logic begins. And this is what determines, you know, who can access your data, how that data is fetched from whatever database it's being held in, any other business logic that you want to happen to process that data before you hand it back. But when you pass in user supplied data into an object as an argument, it gets passed through without being checked all the way down to this resolver function, right into the application logic itself. So this is dangerous because people may not understand that when they're implementing this technology, they none of this data is being sanitized or validated along the way. So let's take a look at an example here. You interact with GraphQL using what are called queries. So let's say we make a query to myawesomeapi.com/GraphQL. You'll notice that the post body contains JSON structured data, and it consists of a top level object, in this case, the hero, with fields nested within it, in this case, name. So if you're familiar with object-oriented languages, you'll notice this kind of hierarchy is similar to how you can have an object with parameters. And you also notice that the response is the same kind of shape as the request. So this is another great thing about GraphQL, is that you can kind of know what to expect back based on, because it always follows the same shape as the request. So fields in GraphQL have what are called scalar types. In this case, the scalar type of the name field is string, and we can look at a schema and be able to tell what to expect back. It's going to tell us that this is supposed to be a string. So we always kind of know what we're dealing with when it comes to it. So similar to before when I was talking about object-oriented languages, object parameters, object fields in this case can have other objects as fields also. So you can see how you can kind of nest this down, and fields can become, or the structure can be very complex. So in this case, we're going to send a request. We're going to get the hero, and we want its name, and we also want all the friends in the database that are connected to the hero and this and their names, and we can do this all in one request. And when we look at the schema later, we can expect a string of objects back, or I'm sorry, an array of strings back based on the schema again. So the schema is really defining the entire structure of the data that we're going to get back. So we're going to talk about types a little bit here. This is what the back end would look like from the schema perspective. So when you're defining your schema, you'll see that we can have, the object type at the top level, and then the scalar types defined for different fields underneath of it. The exclamation point denotes that this is a non-nullable field. The brackets around the type indicate that it's going to be handed back as a list or an array. And we can really tell a lot of everything that we need to know from looking at the schema. So when it comes to scalar types, GraphQL comes with a certain subset of predefined scalar types, but you can also define your own custom scalar types. When you do this, it's up to the developers to validate and that type on their own. So there's no built-in mechanism to just generically handle type validation when it comes to custom scalars. So when it comes to making requests, just like in any other kind of API, we can also define arguments to be sent along with it. It's pretty straightforward. In this case, we can query for a human object with the ID of 1,000, and nested underneath there are the fields, and that's what we're expecting to get back. So again, you can see how the response is the same shape as the request. We get the human with the ID 1,000 along with their name and height. So when you want to update a GraphQL database, right? So with that in GraphQL terminology, that's called a mutation. So in this case, we want to add a category. We can define a bunch of data for it, what goes in it, and then underneath that, we can define what data we want to get back after that mutation successfully executes on the back end. So that's another kind of advantage of using GraphQL. We don't have to make a separate request to get the data that we just updated on the back end. We can do it all and run requests. I want to point out that, again, this is, even with mutations, this is all untrusted data, and there's no way that we can properly attack this thing without knowing that. We have to really press hard on trying different types, trying to spoof the back end by sending all kinds of different types of data. And we can't just make the assumption that they are properly validating and sanitizing all of that data. So I've mentioned schema a couple of times, and how it really shows all the different requests that we can make. So how do we know all the API functionality that exists in here? And we can do that by sending what are called introspection queries. So if you ask nice, GraphQL will just tell you all of the different things that it can do for you. If you worked with SOAP APIs in the past, this is similar to a WSDL file. But you can request just a portion of the schema, like you can see on the left on that, or you can send a huge introspection query and basically tell me everything that you have that you can do. So the responses to these queries can be extremely large. You can see I've listed a couple of different APIs that are out there. GitHub's introspection response to this query is 84,000 lines long. So that's a lot of data if you're going to manually try and parse through that and build like all the different possible queries that you can make. And you have to understand the different arguments that are supposed to be passed in there. That's a lot of work to do that. So another helpful thing to know about the way GraphQL works is that there's basically no equivalent to select star from users. You can't say, I want the user object and just give me all the fields that you have in the database for that object. You have to explicitly define which fields you want the data returned for. And this is, from an attacker pen tester's point of view, this is very problematic if they have introspection query disabled. So that gives us no way to really know what all of the huge range of possible requests that we can make are. So GraphQL has a lot of IDEs and consoles out there. They make it really easy to develop in GraphQL. We can also use these same tools to test GraphQL endpoints. If you find a GraphQL endpoint somewhere, you can typically find the console that they used to test and develop that. So this is a bunch of popular locations that you might be able to find that particular user interface for it. You can also download these as browser extensions or even standalone Electron apps, and they provide a really feature-rich environment for you to kind of point it at a GraphQL endpoint and be able to send requests and see responses. If they have introspection query enabled, these consoles will make that request and parse the data back to build documentation on the fly about the API itself. I just want to kind of talk about real quick why you would want or not want to have introspection query enabled or disabled. If you have some kind of software as a service product and you have a public API out there, it kind of makes sense to have introspection query enabled. You want people to be able to build documentation on the fly and interact with your endpoint without having to have separate documentation and all this different stuff. So in that case, it really makes sense. But if you have a private API that requires authentication, it's used for a authenticated experience, and you have just kind of your own dashboard that's using this API. You may not want to have introspection query enabled because the point of the API wasn't to share it publicly like that. But you'll find that that's not always the case, and people don't necessarily understand that this even exists, or that it could give such an advantage to attackers by having that enabled. Some of these GraphQL server implementations also have a debug mode. So if you tack a debug equals 1 into the URL, that could enable debug mode for that particular server implementation, and that can give you like full stack traces back and all kinds of other verbose errors and additional debug information. So I want to talk real quick about the GraphQL security model, and I want to say real quick because there really isn't one. There are no built-in authorization and authentication features in GraphQL, the specification. So it's up to the server to either try and implement that in a way itself. But yeah, so if they did it wrong, then, and you'll see coming up soon that that's a common error, is implementing the authorization and authentication logic incorrectly, because it can get complex. There are best practices and pre-made libraries out there that developers can use. But are they implementing them correctly? Do they really understand how the library implementation works? So hopefully, maybe as bounty hunters, we can take advantage of some of those implementation errors. So let's take a look at some GraphQL bloopers that have happened in the wild here. The first one that I like to talk about is kind of funny. It's a horrible instance of sinister hackery where these two hackers used wfuzz, and they were searching for subdomains and Shopify cloud.com, and they found one that existed at beerify.shopifycloud.com, and that endpoint allowed them to enumerate all the different offices locations that Shopify Cloud had. And from there, they were able to pivot and query for all the beer remaining in the kegs at that office, because they had, I guess, some internal app that tracked, how much beer was left in kegs, and some metadata around all that stuff. So when they disclosed it, they did it in a kind of a funny way. There was a bug bounty contest going on at the time, and they proposed that they could bribe the Shopify Cloud judges by knowing their favorite type of beer and sending them beer. So um, it was pretty cool of them to find that, and in return, Shopify awarded them with $802.20, which is the approximate price of 3 kegs of the favorite beer that they drank at Shopify. So the next one I want to talk about, it gets a little bit more serious. This one happened at HackerOne, and this was an authentication bypass. They found that the team object would return confidential information about teams, and from that information, they were able to enumerate, by making a lot of requests, all the different companies at HackerOne that were running private internal programs. So from that report, they were able to squeeze out $2,500, which isn't bad. This next one is a great example of really understanding GraphQL and how the server implementation works and how the libraries that you're using work. So they were migrating to a new backend setup where it was a Ruby class-based API implementation for GraphQL. And this introduced a new field into their schema by default. And they previously had a nodes field, but it was nested underneath an edges field. So they just kind of assumed that this was just a shortcut to that previously existing nodes field. But what ended up happening was that wasn't the case, and that nodes field bypassed all the authorization logic to their backend. So they were awarded $20,000 for that find. This last one was old school SQL injection with a new school GraphQL twist. This allowed the attackers to extract information from the public and secure schemas, although it was found after an investigation that this was never abused. There was no payout for this, I suspect, because the person who reported the bug actually worked for HackerOne themselves. So this happened when they implemented a new embedded submission form feature, and instead of using a traditional form field, they wanted to pass that information submitted using GraphQL parameters instead. And previously, the form fields went through automatic input validation and sanitation process. The GraphQL parameter didn't follow that same application logic and gave them access. So I want to talk about abusing GraphQL a little bit. How do we actually go about attacking this platform? So kind of the first thing you have to do here is find the different endpoints, and there always isn't just one go-to spot for that. There could be, it could be located anywhere, just like any URL, but there are some ones that it does typically show up at. And here's a big list of where to start with this. So the left is just kind of the typical endpoint it sits at, but we have to remember that it usually sits behind some kind of versioning URL parameter. But at the bottom is the one where GitHub is located at, just so you can get an idea. It's located at, it has a subdomain, it has a version, and it's using the Explorer endpoint. So introspection queries are enabled by default. This is something that is important to understand, that if you want to disable GraphQL, you actually need to use a separate kind of extension or plugin to do that. But once we find the GraphQL endpoint, we will see if introspection query is enabled by sending a request to it. And if it is enabled, then we get the big old response back. And from that response, we need to parse through it and determine all the possible queries and mutations that we can build from that. And then we need to test each one, looking for authentication and authorization errors, as well as other vulnerabilities. So we need to be on the lookout for error responses that contain stack traces or other useful debug data. This is a lot of work. This is a very time-consuming process, especially on an introspection query response that's 84 some thousand lines long. This can take a really long time to accomplish. So I just want to show an example here of me using the Altair GraphQL client. It's set up to the Snowtooth API. I'm going to send an introspection query and proxy it through burp. So you can kind of let this run. And this introspection query response here is 3,279 lines long. So that's pretty long. So let's see what we can actually get out of that. What does that actually give us? So to do that, we can use a tool called GraphQL Voyager. We can take that introspection query response and copy paste it into GraphQL Voyager, and it will give us an interactive diagram that lets us visually explore that schema. And this is a really interesting tool. It's really helpful when you're trying to understand the complexity of the schema, what things are connected together and where they're connected together at, what are the different fields that I can request for different objects, and all that kind of stuff. So this is what those 3,000 lines gave us, was 3 objects with fields connected to them. So let's take a little bit closer look at understanding what the introspection response looks like up close. Here we have a query for all lifts, and we can get the status for each lift. So you can see it's all in JSON. You can see that the fields are nested under the object the same way they are when you're doing a request. It's all pretty straightforward. We also have another field here on the right called lift, and this one we can pass in an ID and we can get a name and some other data back from this. I just kind of wanted you to I wanted to take a look at here and see how we can build an actual query from that introspection response. So if we wanted to query all lifts, this is what we would actually send it. We would send the all lifts object, and we're saying we want the name and status back, and this is the response we would get from that. This is how we would query that lift object by passing in the ID. We're going to ask for the status, and we're going to ask for all the trails that this lift has access to, and we're also going to ask for the name and status of those trails. So you can see how you can build out queries that can get you a lot of data back all in one request response lifecycle. So this is what a mutation would look like here. We're going to create a review for an episode. We're going to structure it here. This is using a kind of one of these consoles that makes it really easy to work with this different stuff and kind of see how it's all separated out. At the top, we're going to build the structure for the mutation. We're going to pass in some variables. It looks a lot like a function. At the bottom, we're going to define the variables to be passed in. And we're going to ask it to create the review with that data. And in response, we're going to ask for the number of stars and the commentary. So what do we do if introspection is disabled? So this situation makes it very difficult, right? But there are still some things we can do. And one of those things is let's check the staging and developer subdomains. Many times they will disable introspection query in production, but they will not disable it on their staging and development domains. And they also typically don't have their staging and development domains behind any type of authentication. So if it's disabled in prod, just go check their staging and dev stuff, and it's possible that they have introspection query enabled there. We can do the introspection query there, get the response back, and start to build queries that we can use on the production domain. Obviously, we use Burp proxy to click around on the actual website itself that's using the GraphQL backend, and we capture all these requests and responses in Burp so that we can start to kind of build and see what kind of queries we have available to us. Then we can pass those to Burp intruder and repeater, and we can use a technique that I like to call field stuffing. Somebody else might have another name for this that I don't know of, but what we're going to basically do is take a known good query, and we're going to start just adding fields to that query that we think might return us data. I've had in the past added for a user object, I just added the field _password and actually got hashes back, because on the back end, they were just mapping fields to database columns. And whatever I would pass in, it would just retrieve that database column, because I guess that was more convenient than having to, build whitelists and this different stuff and that complex application logic. GraphQL will also do a really handy thing and give you suggestions. So we can see here that we must have made a query that it didn't have a field for, so I sent it a query called create for a mutation. I'm sorry, called for create user. And instead of just telling me no, it can't do that, it actually tried to suggest different fields for me to use instead. And from that, it's like, did you mean create user, create profile, create avatar, or create session? And I'm like, well, yes, I did mean all those things. So I'm going to go ahead and use those instead. So let's take a look at some attack techniques that we can use against GraphQL. So we can take this nested object here and just kind of pull it out and use it as a root query. And in the past, I've had this actually work where, I can't get the friends of a particular user. This isn't the exact case, of course. But if I pull it out and I just ask for friends, it will give me all the friends of everybody in the entire database. So this is a technique that you can try to bypass authentication logic. It could work. It's worked for me. You can also send malicious queries. So if you take a look at this schema definition here, this work was done by Matt Stoiber. I really just want to call him out on this. He has this blog article. I can post all the links to this after the talk, so you can go read about it. So essentially, we have a thread type that returns a message type that accepts a thread type, and a query type that returns a thread based on an ID. So you can kind of see the circular reference starting here, where they're all kind of dependent on each other. So what if we sent it a request like this, that just repeated, nested and nested and nested? So you could definitely crash a server. Any number of bad things could happen sending it. So if you're a developer watching this, be careful that you don't have this circular reference going on. Is deprecated is a GraphQL kind of metadata field that allows you to deprecate a field. And this is mostly used for consoles when they're building their dynamic documentation. You can also define a deprecated reason, and a lot of times they'll state along with that reason the field that is going to replace that particular thing. So that doesn't mean that even if something is deprecated, that the logic around it is built so you can't use it anymore. So a field may have been deprecated, but it still returns data that wasn't intended to be shared. So it's worth still checking out. Oftentimes, mutations are not permitted on any endpoints without authorization first, but you never know. So try and send mutations without being authenticated. You never know that you may end up being able to actually write a new user to the database that you can turn around and use to actually log in as. That's happened before. If you do have to authenticate, try and send all the mutations that you can find in there anyway, because the authentication logic around who can do what mutations may not be implemented correctly. So this is kind of a example of a query that you could send with SQL injection in it. You would pass in your SQL injection with the arguments, or you could just pass in a custom injection marker and use a tool like SQL Map to kind of go through those types of things. Since GraphQL uses resolver functions to facilitate the execution of application logic under the hood, again, I can't stress it enough. It's up to the developers to implement the proper validation and sanitation logic behind that. And if they don't do that, or they don't use, a qualified library, then as we saw in the previous example, SQL injection is also possible within GraphQL. So this is some great work done by Pete Corey. There's a link to the blog post about this, showing how no SQL injections are actually also possible using GraphQL. Since you can define your own custom scalar types, they have libraries out there with predefined custom scalar types for people to use. But if they're not implemented correctly, then you can still take advantage of that. So let's say you have the query type and you're going to search for users, and you have some options that may be controlled by a filter on the front end. And on the back end, in the definition for this resolver function, just takes the user supplied JSON data and dumps it right into the actual functionality itself. So in this case, they're just going to trust user supplied data since it's in JSON format. Adds a little bit of extra complications to it. So what if we sent it a request like this? And since they're just passing our data right in, we can just enumerate all of the users in the database along with their IDs, usernames, full names, and emails. Since for the fields object, it's also accepting our user supplied data. So which in this case is the form of a regex. So you can see the dangers with this. In this particular case, comes from a MongoDB example. So kind of the workflow for attacking GraphQL kind of goes as follows. First, you have to find the endpoint. Then you test to see if introspection query is enabled or not. If it is enabled, we can retrieve the schema and we can parse through that and build queries and mutations off of it. We can add our custom injection markers. We have to make all of these requests, then put them all through Burp Suite, analyze those, try and find a vulnerability, and then hopefully profit. If introspection is not enabled, then we have to click around, capture a bunch of requests going from the front end to the GraphQL backend. And then from there, it's pretty much the same. We're going to take that and try and parse and build as many queries as possible, which will probably be less than if they had introspection enabled. We can try some field and object stuffing to see if we can guess something correctly, set our custom injection markers, make all the requests, put them through Burp Suite, and maybe make some money that way also. So let's talk a little bit about how to protect GraphQL for people that are actually using that out there. Don't enable introspection queries unless you absolutely have to. I know this is like security by obscurity in a way, but you can see from the previous examples about how not having this enabled really makes testing difficult for a bad guy, and really kind of limits what they're able to accomplish as far as that. Of course, we have to say this again because we still find these vulnerabilities out there. Don't trust user supplied data ever, and always validate and sanitize any user input. Well-tested solutions exist for this. There's projects like GraphQL Shield that and adds another layer of abstraction there that lets you set permissions for a field level and all kinds of different nice stuff like that. Use directive-based permissions. Really understand if you're going to use another library, how this thing works, and make sure you're actually implementing it correctly. To protect against denial of service, there's a couple libraries out there that will do what's called query cost analysis, and that's a technique used to measure whether a query is too complex to execute. And you can set a threshold, and if the query complexity meets that certain threshold, you can just reject the query altogether before you send it along and actually allow it to do damage. Do security-focused code reviews with your team. Train your secure coding skills. Try and get training for your programming teams if you're working with this stuff, to make sure that you understand how attackers are attacking your infrastructure so you can protect against it. Also wanted to call out this attack tool written by Paolo Stagno. You can see him at voidsec or at void_sec on Twitter. This GraphQL security toolkit will take an introspection query and generate a bunch of kind of generic requests for you that you can kind of use. He's also going to be releasing this as a Burp extension, which is going to be really handy to have this all built right into Burp. But until that, I've also written a tool called ShapeShifter. So let's just kind of watch a demo and I'll explain how this is working as it goes through. So you can pass in a URL and a proxy for the test. In this case, I'm just going to proxy it through Burp Suite. And what ShapeShifter does is it will just go and check a whole bunch of the common endpoints. It's going to try different versions of all those endpoints. It kind of builds a matrix and tests all of them to see if it can find a GraphQL console or endpoint. We'll just sit here in awkward silence for a moment. So once it finds one, it will parse that introspection response. And I have a bunch of functionality in there to detect the different scalar types, including a bunch that aren't defaults that come. I went and looked at some different libraries out there that had custom scalar types that developers could easily use, and wrote a bunch of functions that generate legitimate data to pass in as arguments in there. And then it's going to try and make all of these requests that it's written. And if it gets a non-200 response, it's going to it's going to check and see if GraphQL is making a suggestion of a new field that it should use. And if it is making that suggestion, it will rewrite the query on the fly using that suggestion and resend it to try and get you a bunch of 200 responses. You can see some here that have still failed. The tool is definitely in early alpha stages. I'm going to be refining it, adding a lot more functionality in it. When I have time, pull requests are happily accepted. So what you end up with here at the end is a bunch of requests that have 200 responses. So you can filter out all the bad requests there. Look at only the 200 responses, and you can start passing them into other tools like Intruder and Repeater. One of the features that I want to build into this is that when it creates all of the example requests, it keeps track of all the 200 responses, and then it can rewrite all of those requests again to an actual file that has custom injection markers already put in the right spot. So you can just take that and pass all of those into SQL Map, and SQL Map will go through and try for SQL injection attacks on all of these different requests. Another tool I like to call out is by Mike Hodges, and it's called Hide and Sneak. And it's a command line tool that lets you set up ephemeral cloud infrastructure that you can use for domain fronting. So if you find that your requests are being blacklisted, like from your IP address, you can really quick spin up some cloud infrastructure, proxy the requests through that, and now you can send requests on the behalf of CDN providers, which bypasses a lot of that. And that's kind of all I have right now.
Alrighty, well, we can see if anyone has any questions in the chat. For those that are watching the live stream, please throw in your questions in the Twitch chat, and we'll try to answer them on screen. We've got 10, 15 minutes left. All right, we got to... Are you, do you have the chat up there, or would you like me
Yeah,
to
I do.
read them for you? Okay, well,
No, I got it up now.
Yeah, Geeky Shivam asked, how do you deal with large responses of introspection queries?
Yeah, so he said he tried GraphQL Voyager and it crashed. This is true. I also had GraphQL Voyager crash for very large introspection responses. So I don't have a great solution for that right now. Something I have done is kind of manually broken up that response into smaller JSON pieces. You know, you got to add in the right curly braces in the right spot to do that, to try and break it down into some smaller responses, and then until I found a threshold that GraphQL Voyager would accept. There's a few other tools that I want to experiment more that do the same type of thing as GraphQL Voyager. But I haven't really had a chance to mess with them too much yet. So I guess some people have better luck than others using this. I don't know if it has something to do with the actual size of the response or the actual complexity of the response. Like how deeply are these things nested? So, but the best thing I found with it is that GraphQL Voyager is free. So if someone does find a way to do this, make a pull request to that project. I'm sure that they would absolutely love to have some of these problems solved. So the nodes and edges and the graph, he said, what is nodes and edges in GraphQL? I have seen this many times in GraphQL query. Is it something defined in the schema or the standard GraphQL field? So it's defined in the schema, but it's not necessary in the spec. And that's usually just some defaults that the actual different server implementations that use GraphQL have built in. And it's kind of just a way for them to structure their schemas using generic fields and objects so that the developers have more flexibility. But it's not in the specification itself that I know of that you have to have that. Are any resources to practice and get better at hacking GraphQL? I would say go into BugCrowd and find some projects that are using GraphQL and practice there. There are occasionally a hack the box here and there that have it, but I haven't found like a GraphQL playground, for instance, that has some intentionally vulnerable. Actually, now that I'm saying that, I do believe that OWASP Juice Shop, which is an intentionally vulnerable web application developed by OWASP, does have a GraphQL endpoint now. One other thing that is kind of interesting to mention is that I found out the other week that Magento 2 has GraphQL built into it by default now. So if every Magento 2 website that's out there, if you just tack /GraphQL onto the end, you'll be able to hit up their GraphQL endpoint that's built in and enabled by default, whether the people using that project understand it or not. And I want to mention that because I don't know if you've ever had to, I feel like having it enabled by default is the wrong way to go with it. If you've ever had to update Magento, it's not a straightforward, easy thing to do all the time. And if a vulnerability was disclosed for Magento 2 within their GraphQL schema, it would force a lot of people to have to suffer from this vulnerability that don't even know that their Magento 2 store has GraphQL. So they don't even know what it is. They're like, oh, well, we don't use whatever that is. Little do they know their store is sitting there vulnerable because this endpoint is enabled by default. Try and catch up here. If you're beginning in GraphQL, how do you approach a new website? First, learn as much as possible about GraphQL. Go read their documentation, understand the intricacies of it. Use a tool like mine or like VoidSex to try introspection query with it and have it auto parse those results out into something for you. And just start slow. Start sending these queries, start changing things with repeater, start to understand what changes in requests cause what changes in responses, and just take your time and really just kind of educate yourself on what you're dealing with as much as possible. Look down here.
Is there like a built with profiler or something like that that people can use to identify GraphQL implementations out there?
Sure. So I don't know about the built with, but there are some kind of key distinguishing features that GraphQL has. And one of them is the question mark query equals in the URL. Typically, GraphQL can accept get and post requests. So if you see get equals in the URL bar, or I'm sorry, query equals in the URL bar, I found that I'll just take that and I'll try and send it an introspection query. And I'm building a cheat sheet right now to kind of get people started with this. It's not quite done yet. I bought the domain name graphqlpentesting.com. So I'm going to have that point to GitHub pages and kind of post some guides and that people can use to try and do this. But if you, and I'll have some snippets on there, like that's something that you can just slap into your URL bar. That's a pre-processed introspection query as a GET request. And even if the introspection query is disabled, you'll still get a response that says, hey, sorry, introspection query is disabled. And if you get that, you're dealing with GraphQL. So the Alkies said Hacker 101 has 3 GraphQL capture the flags. So you might want to check that out. That's helpful information. Thank you.
There was a question about a good GraphQL browser.
So yeah, browser. It's not exactly a browser, but I like to use Altair. That's my personal preference, and it's more of a GraphQL console. Well, but you don't have to use if a website doesn't have a console available, but they have a GraphQL endpoint, you can download Altair as a browser extension, and or an standalone Electron app, and you can just put the GraphQL endpoint right into there, and behind the scenes, it's going to send an introspection query, build documentation, let you kind of browse through the GraphQL's responses in that way.
Looks like we had a question about like a real world example, I guess, of a cool vulnerability that you found using GraphQL.
So I think some of the ones I covered in the talk are pretty interesting. I think that a lot of this stuff is, while some of the other talks that happen today are dealing with technology that's been around for a while. And I've noticed, over time, with the requirements to get an exploit, you got to chain all these things together, do all this different stuff. But while GraphQL has been out for like 5 years now, there's still not a lot of understanding around it. And there's always kind of the pressure from the business side of things on the development side of things to hurry up and pump out all of this functionality as fast as possible. And what that does is it requires developers to cut corners. They can't spend enough time. It's not their fault, they don't have the time or resources to get to really understand if they're doing this correctly. There's not a lot of blog articles out there about how to correctly do things. So it's kind of I found that this kind of lives in the shadows, and something as simple as just passing in a password field with a user request will actually get you hash responses from the database. And um, that to me, it's really mind blowing at just how simple it is. I can just ask for a password and get it back. Um, so doing that kind of field stuffing stuff has been really valuable for me. I'm kind of putting together a word list of common database column names. If you have any, feel free to reach out to me on Twitter. I'd love to get some input on that and really build a robust word list of commonly used database columns, because it seems that it's a common thing for people to just map the GraphQL schema fields straight to database column names and just have a function in there that points them to there. So somebody linked to the Altair. I appreciate that. What would you recommend GraphQL for compared to MySQL, et cetera, for APIs, a bit like GitHub? Um, so MySQL is more of a database implementation, where GraphQL is different than a graph database. And at first, I didn't even understand that. I thought that GraphQL was like a layer on top of a graph database, but it's not. GraphQL is just a middleware that sits between the client and your server-side architecture and takes the query in, parses it out down to resolver functions. And within those resolver functions, every resolver function, if you wanted to, could talk to a completely different database, or it could have even talked to a different API somewhere else. So that it's extremely flexible what it allows you to do. And whatever that resolver function, whatever it's doing, whatever information it gets back and hands back to GraphQL, GraphQL then stitches together the responses from all of these resolver functions into one large response that it sends back to the client. How often do I encounter GraphQL endpoints? More and more all the time. GraphQL is new to me, probably within the last 6 to 9 months. So, but like the Magento thing, I'm always finding out that, oh, these people are taking advantage of GraphQL technology. I wonder if their implementation is secure. You know, I'm not the best at Google Docs. I'll be the first one to admit that. I'm sure that somebody else could create a Google Dork to, like in URL / GraphQL would probably be a good one to start with, and to just see all the websites out there that have, the / GraphQL in their URL, along with you could take that slide, and I'll post this also, of all the different common GraphQL endpoints, and do in URLs for those also. The benefits that GraphQL provides. So latency is the big one. It really, yeah, it provides bounties. Good one. But it really solves a lot of problems when it comes to latency and having to send multiple requests to get stuff. Like, I don't have to send a create user and then query to get that user's ID. I can say, create this user with this data, and then after that is successfully executed, give me all the information that I need about that user back as a confirmation response. So I can do it all in one request, as well as make extremely complex requests and get tons of data back. If I had let's say I was running a sim and I have tons of all this graph, all these JavaScript graphs. I have a huge administration dashboard that's pulling in information for a bunch of different widgets. I can send one request and get a response back that gives me the data I need to populate every single one of those widgets all in one dashboard. If anyone finds any interesting facts out, feel free to reach out to me on Twitter and let me know. I love learning new stuff about GraphQL all the time. And if you have any questions, again, feel free to reach out to me on Twitter as well.
Yeah, do you have like a slide with your contact info? I wasn't sure if you had a slide at the beginning or something like that.
Yeah, let me,
Or we could just like throw up your Twitter account up on the page. But we did
yeah, let me just,
share his Twitter account on BugCrowd's Twitter account. So yeah, reverse
yeah, I just
shell.
put it in there.
There you go. So RVR shell on
Yeah,
Twitter.
let me,
Well,
resume sharing. I'll go back here. There's gotta be a faster way to do this. No, I don't know what I'm doing. We're just gonna all the way back the hard way. We're getting there. Okay, there we go. Yeah. Also, I love skydiving a lot. So if there's any skydivers out there, also
oh,
reach out to
nice.
me.
Well, I guess we could take this one last question and then we'll wrap it up. We had a question from Geeky Shivam asked. Uh, let's see. Is a deprecated field also defined in the schema?
It sure is.
Yeah.
So in the schema, you'll see a field name and then, the definition for it. And then you'll see is deprecated true in there. But you should still send a request to it anyway.
All right. Well, please, everyone, if you're watching live on the Twitch stream, please give him a round of applause in the chat. And if you're watching elsewhere, live or otherwise, please give us a shout out on Twitter, twitter.com/bugcrowd, as well as twitter.com/reverse shell for Matt. That's RVR shell. Give us a tweet, and we will share all this information again in the coming week or two. We should have all these videos up on our YouTube channel.
And I'm speaking at Texas Cyber Summit about this as well. So if anyone's going to Texas Cyber Summit in a few weeks, introduce yourself. I'd love to talk.
Awesome. Well, thank you so much, Matt. We really appreciated your talk here. I think people really enjoyed it.
Cool. Thanks, guys.